Today's lesson is 4.2, which is the rate of change. So today we are going to cover the rate of change, which is just like the slope, only covered with variables and labels. So if we look at example number 1, it asks us to look at the table at the right with a price of vacation resort for stays with a given length. So the question is, what is the rate of change from a 4-day vacation to a 7-day vacation? So if we look, we are looking from the 4-day vacation to the 7-day vacation. So we always put our y variable on top, which would be the cost. So we're going to look at the difference from the 7-day vacation, which is $449, subtract the 4-day vacation, which is $359, and then on the denominator, we're going to look from 7-day to 4-day. And just like yesterday, we'll simplify from there. So 90 divided by 3. So the rate of change is 30. So that looks a lot like slope. But today, now, because we're talking about rate of change, we need to add a label. So the rate of change would be $30 per day. So the difference today is we need to just simply add that label. So we're adding some value to the number. So $30 per day. So question 2, when a bonsai tree was bought, it was 12 years old and H centimeters tall. When the tree was 15 years old, it was capital H centimeters tall. Write an expression for the rate of change in height of the tree from ages 12 to 15. So if we're going to do the height in centimeters per year, that would be what we would be looking for. So we would say our H minus our small h divided by the 15 minus the 12. So we're always looking at that difference. So we'd have capital H minus lowercase h over 3. And our label then would be centimeters per year. So again, we're adding our variables today. And since we can't simplify those variables, we're just going to leave it capital H minus small h. Okay, now we're going to go ahead and look at this temperature chart showing several hours of the day. And notice we're looking from noon to 1 to 3 to 4 to 7. Well, if we're going to try and subtract things, if we're trying to subtract 12 from 1, that wouldn't really give us what we're looking for, because 12 minus 1 is 11. But really that's only 1 hour. So what we're going to want to do is actually change our table. So this would be our 0, this would be our 1, this would be our 3, because that's 3 hours later, this would be our 4, and that would be our 7. So sometimes what we're going to have to do is adjust our scale so that mathematically it's going to give us what we're looking for. So if we're talking in hours, we're going to adjust that again so we can talk about the number of hours so that we can actually talk about what we're looking for, because noon would be our 0, not actually 12 hours. So what number did we need to fix? We needed to fix our 12 o'clock to actually be our 0. So what is the ROC, meaning rate of change from 12 to 0? So from 12 to 0, from 12 o'clock to 1 o'clock, we would be looking at -2 minus -5 over 1 minus 0. So that would be -2 minus -5 would actually be 3 over 1, which would be 3. Again, we're doing labels and we're talking about degrees here per hour. So 3 degrees per hour. Question 3, what is the rate of change in temperature from 1 o'clock to 3 o'clock? So now we're looking here from 1 o'clock to 3 o'clock. So we've got 6 minus -2 over 3 minus 1. So we're looking at 8 minus 2, which is now 4 degrees per hour. Which time frame had the greater range of change, 12 to 1 or 1 to 3? So the higher rate of change was our 4 degrees per hour, so that would be from 1 to 3 o'clock. What is the total rate of change from 12 to 7? So if we look at this entire rate of change from our entire day, we'd be looking at -2 minus -5 over 7 minus 0. So we'd be looking at -2 plus 5. Well, again, watching our negatives here. So that would be 3/7. And then we can just leave that a fraction because that doesn't simplify. Add our label, degrees per hour. And if we were to draw a rough sketch of our temperature here, we would go ahead and put in our labels 1, 2, 3, 4, 5, 6, and 7. And we would need to go as high as +6 degrees and as low as -5. I guess we didn't do a very good job giving us enough space here. At 0, we were at -5. 1, 2, 3, 4, 5. At 1 hour, we were at -2. 2 hours, we were 6 degrees. 3 o'clock, we were, oh yeah. I was off one. 3 o'clock should have been 6 o'clock. 4 o'clock, we were at 5. And at 7 o'clock, we were back down to -2. So the temperature, like normal, as we notice, especially in Wisconsin, our temperature goes up and down. A few more examples we have here. The chart below shows Tom's income for each week of a 6-week period. Graph these points and connect them. So we've got a nice little graph here. So week 1 was $11. Let's see, we should probably rescale here. So we have to get to 25. So let's make this by 5s. 10, 15, 20, 25, 30. So week 1 was $11. Week 2 was 15. Week 3, he didn't make anything. Week 4 was 21. Week 5 was 25. And week 6 was also 25. So A was graph these points and connect them. Okay, name an interval where the rate of change is positive. So we have a few of positive here. We could say maybe from 1 to 2 was positive. 3 to 4 was also positive. And 4 to 5 was also positive. So any one of those would work. Name an interval where the rate of change was negative. We only actually have one of those. And that was in here from 2 to 3 weeks. Find the rate of change of Tom's income between week 4 and 6. So remember your X's and your Y's always go on top. So we've got 25 minus 21 over 6 minus 4. So we've got 4 over 2. So we've got 2, and you're always labeling it now in a rate of change. So we've got $2 per week. Again, labeling it in a rate of change. And when was the rate of change 0? And how can you tell? Well, right here between week 5 and 6, because the slope was 0. Or it was a horizontal line. Either one would work. All right, question 5. Use the graph at the right. It shows the height of Greg's feet as he dives off the board. How many seconds pass before Greg's feet leave the board? So we're looking, he's probably standing on the board right here. So it looks like about 2 seconds before he jumps off that diving board. How long is he in the air? Well, it looks like about 3 seconds right there before he's not in the water till right here. So from 2 to 5, he's in the air, so 3 seconds. About how high does he jump? So right there, he jumps 15 feet. What is happening between 5 and 6? So that's down here. Well, he is underwater, hopefully holding his breath. And how high is the diving board? Well, that's when he's standing on it. So right there, it's 10 feet. So that was just kind of looking at the rates of change and reading the graph. And the following is another one about reading the graph, represents Karen's marathon. Find the rate of change in interval A. So interval A is this one right here. And we're going to find her interval. So we are looking at an ordered pair here, which would be 1, 6, and the one between 0, 0. So she is running 6 miles per hour there because she made it 6 miles in that first hour. What might have happened to her in interval C, which is right there? Well, she hasn't gone anywhere, so maybe she stopped at a water station right there. Okay. And then if Karen's rate of change for interval A had remained constant through the entire marathon, what would have been her finishing time? So if she had run 6 miles in 1 hour and she had to run 26.2 miles, because that's what a marathon is, and you wanted to know how many hours, we would go ahead and set up that nice proportion, cross multiply. That would have been about 4 hours and 18 minutes, which is a pretty decent marathon. Okay, so that's your notes today for rate of change. Go ahead and work on your homework, which is pages 3 and 4.